Okay, hi calculus students, this is video 6-5 for Thursday, February 9th. There's no homework associated with this, and I'm having to start this video all over. So I already have stuff written down because I was doing it and then I got stuck. So region R is the region bounded by this graph, which is a parabola, this graph, which is a line, and the y-axis. Number one, find the volume of the solid whose bases are and whose cross sections, when cut by planes perpendicular to the x-axis, are squares. And then number two, we'll find the volume of the solid whose base is the same region and whose cross sections, when cut by planes perpendicular to the y-axis, are squares. So cross section squares, but cut, different ways. Okay, so in the video I just tried, I graphed this with you guys, and I actually graphed it by hand because I knew that was a parabola, shifted up 2. I knew what that line looked like. I was a little bit thrown off because I know that my vertices are going to be formed by the intersections of the y-axis, the parabola, and the line, but really this line would keep going up this way, so I would have maybe it would have been this intersection, that point, and that point. The directions aren't clear. We're just going to assume it's this section that's in the first quadrant. Okay. If it was on a test or a quiz, it would be clear, absolutely clear what they were asking for. Okay, then I did the coordinates of this vertex 0, 11, this vertex 0, 2, and then this vertex. Pause the video now if you've got to write all this down. Okay, so pause the video now. And then when you're ready, come back to me and we're going to graph these. So x squared plus 2 I'm going to graph, and 11 minus 2x I'm going to graph. Then, so I'm going to graph them. So I'm looking for that point of intersection right there. So I go second, no I don't. I go to Calc, second trace, intersect. 1, 2, 3. And you see these intersection points, you do not want to use an estimate for them. So I'm going to store them in my calculator. Okay, so don't estimate those, let's store them. So if the good thing about this is, since we just used this intersect feature, right now if I go to my home screen and I type in X and I type in Y, you'll see what happens. So second quit for the home screen. So if I just type in X, that's the X coordinate of the intersection point. So right now your calculator is understanding that if you type in X, you mean that. Now for some reason, since we've already got X's and Y's on our paper, I just will feel more comfortable if I store this as a different letter. So I'm going to store that as A. So when I type A, my calculator will know what I'm talking about. Now let's look at Y. So I go alpha 1 is Y, and that's the Y coordinate of the intersection point that we just found, and I'll store that as B. So I go to, you might not remember this, the store button's right down there. So I go store, and then alpha, where's B? Alpha apps is B. Okay, and then I'm just gonna, so I'll say that this is A, B, and then I'll be clear to my reader that I've got, so how was this? So maybe I should go 2.162 ... and then this is stored as A. Sorry, you couldn't even see that. This stored as A. And then I'll say the other one, 6.675 ... This is stored as B. Okay? So just somewhere on your paper so your reader can see that. Okay, so now the cross sections. So for the first one, my cross sections are perpendicular to the x-axis. Okay, so my cross sections, I'm going to be cutting through this way. So I'll use this, I'll take this as like my sample cross section. and I'm going to have to go top minus bottom for the length of that. And let me ask myself now, am I going to need more than one picture over here? And the answer will be yes, if the top function and bottom function change ever over this region. So top function, bottom function, line is the top one, parabola is the bottom, line top, parabola bottom, line top, parabola bottom, all the way through the region. So I'm only going to need one picture over here. So here is that's that same pink line that I drew on the region, the same exact one. And its length, the top function minus the bottom function, so top function is 11 minus 2x minus the bottom function is x squared plus 2. So let me simplify just a little. So 11 minus 2, so I've got 9 minus 2x minus x squared. Okay, that's the length of that. Let me complete the cross section. Okay, it's a square. And then the area of a square is base times height. But for a square, the base is the same as the height, so I'm just going to have this thing squared. So 9 minus 2x minus x squared squared. Okay? So the volume is going to be the integral from x equals the lowest x value is 0. And then the highest x value is that coordinate right there, A. Okay? A, which is about 2.162. All right? And just have this written somewhere for your paper, or somewhere for your reader. This has got to be very clear how you did this here. And maybe you should even, I'm going to be super careful, stored in calculator. All right, that's stored in my calculator. I mean, when people are grading your AP exams, guys, they're professionals. Many of them have done it a lot, but they are human. Don't make them search for things on your paper. Make it very clear to them. Things, I'm sure, get overlooked. All right, it happens. We're all human. So now the input of this integral is going to be the area of the squares. So 9 minus 2x minus x squared. And you know what? I'm going to just leave it to you just for the sake. Actually, never mind. Okay, so equals. I'm going to keep going. And then I'm going to go math 9. I'm doing 8 videos today, so I'm a little disoriented. So 0 up to A. Okay. And then 9 minus 2x minus x squared dx. Okay, so there it is. I'm writing it down on my paper. So this is 75.1215. Okay, so there's the volume of that solid. Now we're going to do the same exact thing for part 2, except perpendicular to the y-axis. So perpendicular to cross section area, and then we'll use an integral to add up all the areas. So perpendicular to y. The reason this is important is because now we know everything must be in terms of y. So back up here, I'm going to solve for y there. So I'll have that x is equal to y minus 11 over negative 2. All right, so those are two ways of expressing the same the equation of the same graph. Okay, and then up here, I'm going to subtract 2, and then I'm going to take the square root. So it's this one, or, this is kind of tight, or x equals the square root of y minus 2. Okay, so right there. So my cross sections now are going to be perpendicular to the y-axis. So like, and I'll start low. Okay, so the cross sections are going to be, like their bases are going to be horizontal lines going through like this. So I'll start low, like down here. Okay. And I'm going to do right minus left for the length of that. So, and let me just decide, am I going to need more than one picture here? So here, like right down here, if I'm low on the region, the right minus left, the right graph is the parabola and the left is the y-axis. So right minus left would be parabola minus 0, okay, because the x-axis is y equals 0. So parabola minus 0, parabola minus 0. But then up here, when you hit that intersection, then it switches to the line minus 0, the line minus 0 for right minus left. So I'm actually going to need two integrals because up here, okay, the base of that cross section is going to be the line minus the x-axis, which would be 0. Okay, so down here into my chart, okay, for my first cross section, all right, there's that green line that I've just transferred. Okay, right minus left, right is going to be the graph of the parabola, so in terms of y, that is radical y minus 2, but then it's minus 0, which you don't really need to write. And then I'll just complete that cross section. So the area is base times height, but it's just radical y minus 2 squared. If you want to simplify that, you could just recognize that's just y minus 2. Okay? But then I have that second interval where the cross sections look different. Okay, so right minus left for that blue line is the line minus 0. So y minus 11 over negative 2 minus 0. Y minus 11 over negative 2 minus 0. You don't have to write minus 0. Okay, so the area of this is base times height, but base and height are the same. Alrighty. So for the volume, we're going to need two integrals because we have two different formulas representing the area. So the volume equals the integral from y equals, okay, so what is so right now we're like on this portion of the region, like on this portion. The lowest y value is 0 and the highest y value is b. Okay, b, which remember is approximately 6.675, dot, dot, dot. So the first integral is starting at 0, and then b, and I'll be super clear, stored in my calculator. Okay, and then I'm using y minus 2 dy. Okay, plus the integral from y equals b up to the highest y value is 11. And then this is y minus 11 over negative 2 squared dy. All right, and you could stop here if you'd like. I'm going to keep going. I mean, if you stop here, please finish the computation, but I'm going to keep going for the video. Math 9. 0 up to b plus math 9 b up to 11 x minus 11 divided by negative 2. Okay, 13.6053. Wow, same region, but a much smaller volume. So just by changing from our bases perpendicular to the x-axis to perpendicular to the y-axis, we had a huge change in volume. Okay, guys, so there's that, and I will see you soon. Bye-bye.